Hello children and welcome back to mathematics class for class 8. We have already learned about the concepts of cubes and cube roots in the previous class. Now we will move on straight to the exercise. We will start with exercise 7.1. 7.1, it is on page number 114 of your textbook. All right children, so let's start with the first question. The question is, which of the following numbers are not perfect cubes? Now, there are a set of numbers given. A set of numbers is given. So, 1, 1. We will do some of the numbers here. We will solve some of the numbers. So, to find if they are perfect cube or not, we will first factorize them. 2, 1, 6. Start with 2, 2, 1, 2, 8. 2, 5 is 10, 2, 4 is 8, 2, 2, 2, 7, 3 into 9 is 27, 3 into 3 is 9, 3 into 1 is 3. So we have 2 into 2 into 2 into 3 into 3 into 3. So we have 3 pairs of 2 and 3 pairs of 3. So we can say that 216 is 2 into 3. The cube root of 216 is nothing but 6. That means if you multiply 6 3 times, you are getting 2. All right. So this is a perfect cube. 216 is a perfect cube. All right. Let's try another number. Let's look at 2. 128. Solution. Now to find factorization first, to factorize first. 2 into 6 is 12, 2 into 4, 2 into 3 is 6, 2 into 2 is 4, 2, 1, 2, 6, 2, 8, 2 into 4, 2 into 2, and 2 into 1. So we're getting 2 into 2 into 2 into, first part is over, 2 into 2 into 2 into 2. All right. So what we are doing here is we are going to group them. This is one group of 2's and another group of 2's. We have an extra 2 here. All right. And these 2 cannot be grouped as a triplet. It has no partner. All of them have partners. This one is left without a partner. So by factorization, if you're getting an extra number, that indicates that this number 128 is not a perfect cube. All right. So these are the examples of a perfect cube and which are not a perfect cube. So please try the rest of the questions at home. We will move on to the next question. Question number 2. 2, 1. The number is 2, 4, 3. The question is, find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. So we have already seen the two methods. One is multiply, one is divide. So I'm sure we are not confused. Let's try to solve this. Solution. First we have to factorize. 243. We will start with 3. 3 into 8 is 24, 3 into 1. 3 into 2 is 6, 3 into 7 is 21. 3 into 9 is 27, 3 into 3 is 9. 3 into 1 gives you 3. So this is prime factorization. So 2, 4, 3. You are getting 3 into 3 into 3 into 3 into 3. Right? So we have a triplet of 3. But here, to be a triplet, we need one more 3, right? So, to make this complete, we will multiply by 3. So, when we multiply by 3, we get 3 into 3 into 3 into, this part is over now. This is one group. And here, 3 into 3, since we are multiplying by 3, it is also complete. So when we multiply by 3 to these factors, this number will become a perfect cube. So we can write like this: when we multiply 243 into 3, it becomes a perfect cube. All right, children. So this is how we will multiply a number or numbers to convert those numbers which are not perfect cube into perfect cubes. All right. Let's look at another example. The next question is 256. Let's factorize. 21, 22, 28, 26, 24, 23, 22, 21, 26, 2 into 8, 2 into 4, 2 into 2, 2 into 1. So this is the prime factorization. I'm getting solution 2 into 2 into 2. This is done. Into 2 into 2 into 2. Another group done. Into 2 into 2. All right. So when we group them into triplets, this is a triplet, this is a triplet, this is not a triplet. It has only 2 2's. That means if we multiply one more 2 here, this number will become a perfect cube. So we simply write like this: multiply by 2. So it becomes 2 into 2 into 2, one group, into 2 into 2 into 2, one group, into 2 into 2. Now this 2 will come here. It has become a perfect cube now. All right. So therefore, when you multiply 256 into 2, it becomes a perfect cube. All right. So this is all about multiplying numbers to make it a perfect cube. Let's move on to the next question. Question number 3. Question number 3. Find the smallest number by which each of the following numbers must be divided to obtain a perfect cube. Now we have 81. This is question 1. Let's factorize. 3 into 2, 3 into 7, 3 into 9, 3 into 3, 3 into 1. We have 3 into 3 into 3 into 3. We have a triplet of 3's here. This is the extra 3. Okay, so we will write now divide, the opposite of multiply, divide by 3. So we're getting 3 into 3 into 3 into 3 into, divide by 3. So this is a triplet. We cancel the extra 3. We are left with 3, which is nothing but 27. So therefore, when we divide 81 by 3, all right, we can write like this. Therefore, divide 81 by 3 to get a perfect cube. All right. So this is how we use the division method to find a perfect cube. Let's look at the next question. One more example. Let's do question number 3. 135. So 135, let's start with 5. 5 2 is 10, 5 7, 3 into 9, 3 into 3, 3 into 1. So we have 5 into 3 into 3 into 3. Here we have 3 as one group of triplets. 5 is the extra number here, extra factor. So we will divide it by 5. So we get 5 into 3 into 3 into 3 divided by this 5. Now this 5 and this 5 are cancelled. 5 into 1 is 5, 5 into 1 is 5. We are left with exactly a triplet. So we can say that it has now become a perfect cube. Therefore, divide 135 by 5 to get a perfect cube. So this is how you do multiplication and division to get a perfect cube. All right, children? So with that, we'll come to the end of this exercise. We have skipped some questions, and those questions I want you to try at home so that you can also practice and learn. All right, children? Let's look at exercise 7.2. 7.2. We will start with the first question, question 1. 64. Now, the question here is, find the cube root of each of the following numbers by prime factorization method. Now here we will find the cube root by prime factorization method. So 64, you prime factorize. Start with 2. 2 into 3 is 6. 2 into 2 is 4. Again 2. 2 into 1 is 2. 3 minus 2 is 1. So 1 will carry it here. It becomes 12. 2 into 6 is 12. 2 into 8 is 16. 2 into 4 is 8. 2 into 2 is 4. 2 into 1 is 2. So we are getting, for 64, we are getting 2 into 2 into 2 into 2 into 2 into 2 into 2. I'll remove this 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So when I make a group of triplets, this tree will become a group, this tree will become a group. All right? So by grouping, we can say here 64 can be grouped into triplets of equal factors. We will not be writing all these in the answer. This is just for your understanding. Here 64 can be grouped into triplets of equal factors, meaning into triplets, and all the numbers in the triplets should be same. If it is 2 here, all the 3 of them should be 3. All right? Sorry, it should be 2. And similarly, if it is 2 here, all of the 3 numbers will be 2. Therefore, 64 cube root, okay? Cube root of 64 is simply, from these 3 triplets, I take only 1, 2 now. All right? And from these 3, I take only 1. So I can say that 2 into 2 is 4. Therefore, 4 is the cube root of 64. All right? Therefore, 4 is the cube root of 64. That means if you multiply 4 3 times, you will get 64. All right, children? Let's look at the next number. 512. Let's do its prime factorization. 2 into 2 is 4. It goes on. 5, 6, 2, 1, 2, 2, 2, 8, 2, 6, 2, 4, 2, 3, 2, 2, 2, 1, 2, 6, 2, 8, 2, 4 is 8, 2, 2, and 2, 1. All right. So we have, first let's write this tree, 2 into 2 into 2. Then this tree, 2 into 2. Then this tree, into 2 into 2 into 2. All right. Now we have 3 triplets here. First one, second one, and third one. So this can be written as cube root of 512 is, from each group I will take only 1, 1, 1, 2s. 2 into 2 into 2. That means from here I took 1, 2. From here 1, 2. From here 1, 2. So 2 into 2 is 4, 4 into 2 is 8. Therefore, 8 is the cube root of 512. Alright children, so this is all about finding cube roots through factorization. Let's try one more number for better understanding. Let's try question 8. 46656. Let's find the factorization. 46656. Let's start with 221. Sorry, 224, 236, 236, 2228, 21, 2126, 26, 24, 25, 10, 28, 23, 22, 22, 9, 21, 26, 21, 248, 25, 10, 28, 27, 22, 29, 3, 2 are 6, get 1, 3, 4, 3, 3. Let's bring this up here. 2, 4, 3, I do with 3 again. 3, 8, 3, 1, 3, 2, 3, 7, 3 into 9, 3 into 3, 3 into 1. So for this, I will write 2 into 2 into 2. Again, for this 3, 2 into 2 into 2. And 1, 2, 3, all right? 3 into 3 into 3. And finally, this 3, 3 into 3 into 3. So when I write a cube root of 46656, I can directly write from here, I take only 1, 2. From here, I take only 1, 2. From these 3 trees, I take only 1 tree. And from these 3 trees, I take only 1 tree. So when I multiply, 2 into 2 is 4, 4 into 3 is 12, 12 into 3 is 36. Therefore, 36 is the cube root of 46656. That means if you multiply 36 3 times, you will get 46656. So this is all about finding cube roots using factorization method. All right, children? So to be able to understand properly, please practice the numbers that I have left out. I have left out a few numbers so that you can practice at home. So please practice, and it's not very hard. You simply have to understand this prime factorization. You have to learn how to factorize. If you have difficulties, you can always take help from your teachers and your elders to help you with this. So please continue to practice and study hard, and I will see you again very soon in the next class. Till then, take care. Bye-bye.